Hello, STEM Nation. Jeff here, and welcome to episode number 54 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share it with a friend. Now let's get fired up with our guest, Chris, and I hope our chat will help ignite your passion towards a STEM career. Chris earned a Bachelor of Science in Electrical Engineering from Kettering University and a Master's in Electrical Engineering from the University of Michigan. He is currently a field applications engineer for a large semiconductor company. Welcome to the show, Chris. Fill in any gaps and share a bit of your personal life.
So as you said, electrical engineering has been my thing throughout my schooling and my career. And now my wife and I have a son who's starting an engineering adventure at Michigan State. Go Green. And that's allowed me to kind of reflect on what I've done and help him choose what he's doing. And hopefully it will help me give your listeners some perspective too.
So thanks for that, Chris. What's some guidance that you actually gave your son as he was looking at different types of careers to go into?
The guidance there is do what you're passionate about. Do what you love. It's what drove me into choosing my career path, choosing my degree, and my guidance was to him was to go do that, pursue it, learn about it, and just follow your passion.
All right, Chris. So let's get in here a little bit. So you got an electrical engineering degree. You're a field apps engineer. But I was looking at your LinkedIn profile, and you have a pretty varied, path of experience from about 1990. It looks like you've had a couple of different types of careers along the way. Could you delve into that a little bit?
Yeah, in all of those experiences and the work that I've done, I like to sort of describe myself really as a computer engineer. Even though my degrees were electrical engineering, I was passionate about computers. I first got my experience actually with computers at a STEM camp, of all things, maybe 5th, 6th grade. Didn't call them STEM camps then. But it was really the same thing. It was an opportunity to get kids interested in the technology of the day. The technology of the day then was this upcoming thing called the computer, and really kind of the personal computer. But this personal computer that I particularly worked on didn't even have a screen. It was a keyboard and a printout. And there was a game that you had to figure out how to land a lander on the moon. And you typed in these things and you got these results. And strangely enough, I was hooked. And so all of my background and all of the things that I've done have always been around how to take the computer, learn about its hardware, learn about its software, and do something fun, exciting, and useful.
All right. So you've got some insights here. So you say you're more of a computer engineer, but you've got an electrical engineering background. And since your son was heading off to college, if somebody was really interested in computers, what would you recommend? Going electrical engineering, computer engineering, or computer science?
So a lot of it involves where your fundamental interest is the most. For me, I was always interested in what made that computer tick and how it translated the things that the programming, the languages, and the things you wanted to do, how it actually worked. I first actually started after that STEM camp, getting involved in programming. And learning about how to use the computer. But I always wanted to know why it worked. And so I pursued my electrical engineering degree focusing on what was making the computer go under the hood. Some other people they just want to make it work. They just want to do useful things. Computer science is that art of really taking the hardware and doing unlocking its potential and doing everything that you can do with that computer. And electrical engineering as a more pure form, you're going to get so much more broad exposure to all the different facets of electronics, and for people who want to be broad and learn about all the different things from motors to radio to computing itself, that might be the thing that helps them kind of choose their direction.
All right, thanks for that, Chris. And let's dig into what is your specific area of expertise?
So right now, I'm focused on a particular type of computing, which is reconfigurable hardware. So it's called a field programmable gate array. And it's been in the industry for quite some time, and recently has been getting a lot more of interest and activity because computing is becoming so very specialized, and there are so many things. It just permeates everything we do today, right? And so we're now needing tasks to have very specific kinds of computing and adapt those very, very rapidly to new problems. So this type of hardware allows you to actually change the circuits much like you would change the software and deploy a new circuit, a new idea, and do something that's completely unique.
So you're a field apps engineer. So what does that mean? Are you doing design? Or field meaning out in the field, or what does a typical day look like for you?
Yeah, so a field application engineer is kind of a broad topic, but it really involves helping customers learn, use, and make products around a particular technology. So in this case, these programmable gate arrays, I help work with the customers to take their ideas, help show them how that technology allows them to realize those ideas, work through problems that they're having, and support their development of that product, support it through its entire life.
So you mentioned talking with customers. So is this more of a sales role, or are you sitting behind a desk working on designs? Could you explain that a little bit more?
Yeah, one of the fun things about the role is that it's not always behind the desk, and very often it's in the customer's lab helping them with a particular problem, or working with other sales professionals that allow you to kind of sell the idea and help somebody realize the power of the technology for the company that you work for.
This is STEM Nation, where we've got juniors, seniors, and I guess even parents listening to the podcast. So a student that's going, yep, I want to head down the STEM route. I kind of like this field applications, this FAE role. What would you recommend to somebody heading down through college, getting out of college, and thinking about an FAE role? Would you recommend that they go do some design for a while, or is this a type of role where you can come out right out of college and do?
So one of the things that makes field application engineers really, really valuable is they usually have broad experience where they've done some design. They've worked in teams. I think that's a super important part of being successful in the role, is that you've spent some time working with other professionals across a lot of different types of technologies. And we do that so much today. Technology is so complicated that you have to work with all sorts of different disciplines: software people, mechanical engineers, other hardware engineers, business development people, manufacturing, productization people. And when you can get those experiences and work with all those different types of people, then you can step into this role where you can help other people chart that course and work on a variety of different aspects of what it takes to actually make a product.
Great, Chris. Thanks for that insight. And we're going to move on to a little thing that has you fired up. What is one thing that really has you fired up in the field of FAE or field programmable gate arrays, or anything in general?
I think I'm fired up about where computing and the next generation of these students coming into STEM can take it. We're just so many big problems out there to be solved, and we've seen over the years, as the computing technology has gotten better and better and better, that we're able to dig into the really, really tough problems and really do things that are amazing, that couldn't be harnessed before, maybe like when you and I were in school. Now this generation is going to be able to take these advances and really unlock some of the great questions in science, and use that as a tool to build something for other people.
All right, that's awesome, Chris. And everybody loves a story. So take us to an aha moment you've had, and tell us a story and how you turn that into success.
Okay, so my story comes around about the junior time frame of my years in college. It's getting really tough at this point, and you're starting to concentrate on your electives, your those core classes, those topics that you really, really always wanted to learn. And so I was finally getting down to the good stuff in my electrical engineering degree, and I was excited to take my first detailed circuits class. And this was going to teach about how the circuit worked inside, and the transistors, and how it ultimately came together eventually to make a computer. But I was lost. Our first problems were 14 transistors with 2 initial values, and I was supposed to solve where the voltages and currents were at every node in this circuit. I couldn't even imagine how this was possible. I struggled and I struggled and I struggled. I struggled on my own, and I finally desperately needed some help. And I went to the dreaded office hours. No one wants to go to office hours, right, and go ask the professor. But I finally had to. And my professor quickly found out that I knew what I was talking about. I read the material, was enthusiastic. I had the math skills I needed. And then he finally delivered some of the best advice that I've ever gotten. which was stop worrying about what you don't know. Pick one small step of the problem, solve it, and that answer leads you on to the next part of the solution. I was getting paralyzed with all the complex possible solutions, and I just didn't pick a place to start. And that sort of mental attitude of not getting overwhelmed with complicated problems, because in engineering there are very complicated problems, and just being able to take one particular thing, analyze it, and move on from there has served me both in school, with my professional career, and in my life in general.
Yeah, STEM Nation, take that big problem and break it down into tiny steps and just start. Just start with that initial thought, go solve it, and see if it takes you to the next step. And that is the key with, I think, most of these STEM curriculums is it teaches you how to solve a problem. If Chris didn't go for a STEM curriculum, I don't think he would have figured that out going for a different degree, which is why a lot of companies hire engineers and STEM professionals for things unrelated to their degree. Absolutely. Because of that problem-solving capability.
Yep, that's right.
But, in order to get through college, it's challenging, right? You saw that with your circuits class, right? It's challenging. How do you solve this? How do you solve this? You're spending all this time. What advice, Chris, would you have for these juniors and seniors heading off to college?
I think one of them is certainly don't be afraid to fail. And that failure is a very powerful teacher and a very powerful way to overcome. Actually, in my freshman year, I went away to school with my very best friend, who sat in the back of our calculus class as in my senior year of high school and slept. And I sat in the front row and worked my tail off, and still didn't get an A in that class. But when we went away to college together, and we were challenged with a whole new set of really hard classes. My friend, he did not know how to study. He did not know how to fail. And by the end of his freshman year, he had just given up. He didn't know how to recover. He didn't know how to study, and he didn't know how to work back from not getting the answer right away. It's okay to not get the answer right away, and in fact, in engineering, that happens almost all the time. What's important is that you've got to keep at the problem.
So that was your high school friend. You went off to college with him, and he was one of those statistics. Roughly 50% of the students don't make it through these STEM careers, don't make it through engineering. So he was one of those statistics. Is that true?
Yeah, and again, it was really not having seen how to do the hard work, and that's one of the things I try to share with my son. Actually, doing the same thing, going through calculus as a senior, struggling to get through the problems. And one of the things that occurred to me, I realized in watching what he was doing and watching what I had done, is that this is why people who choose STEM careers get hired, is because they can work through a hard problem and not give up, and they can fail and get back at it and solve the problem. That makes all the difference, and that's why people want to hire people who have STEM backgrounds.
Yeah, and so STEM Nation, this has come up before, right? If you're junior or senior in high school and you don't really have to work that hard, you probably want to go get some tougher material, or at least start to learn those study habits. You need to push yourself. You need to develop that grit, or you're going to be in for a rude awakening when you get off to college, and you don't want to end up as a statistic and maybe end up as a business major, God forbid.
Well, certainly not.
Certainly not. Nothing against business majors there. So, Chris, what are some attributes that you had to develop or that you see are as important as you launch from college into your career?
I think one of the things that maybe doesn't get emphasized, or maybe in my time at school didn't get emphasized quite as much, is that networking that you should do even when you're in college, reaching out to your professors, doing things that internships and other types of things where you're broadening yourself, you're working with other people and other teams, and you're kind of developing those links already of common interests, both professionally or academically, and I think we just underestimate how much those open the door to opportunities. Sometimes it's not it's not direct. It's very indirect. It's a friend of a friend, or it's something that you didn't know about, but because you've exposed yourself to these other networks and these other opportunities and these other activities, I think that you get the benefit and you give the benefit too. And I think I underestimated that when I was first starting out, kind of trying to do everything on our own, right? And I think that's an engineering discipline to some extent, is that we want to all have the answer and we want to solve the problem, be the smartest person in the room. That is not what helps make you successful. It is really about how well you can work with other people and then take everybody's smart ideas and do something amazing.
Yeah, Chris, the network is so important, and LinkedIn. If you're not familiar with LinkedIn, go to the LinkedIn.com website. Start building your network. If you want to connect with Chris and just reach out, if you have some questions from this podcast, reach out to Chris. Go to the show notes up on STEMonfire.com and click on Chris's name, and it'll take you right to his LinkedIn account and connect with him and say, "Hey, Chris, I heard you on the podcast, and I got a couple of questions." I'm sure Chris would be willing to help you out.
Absolutely. I would love that.
All right, Chris, so we're going to take a quick pause and thank our sponsor, Audible, who's offering a free audiobook. You get over to STEMonfirebook.com, that's STEMonfirebook.com, to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep the audiobook. Chris, are you ready for the lightning round?
Well, Jeff, I am an electrical engineer, so I'm always ready for some spark.
Get ready for some spark. All right, what's the best advice that you've ever received?
I think, again, it goes back to my aha moment, that advice to just stop worrying about what you don't know and just work the problem and start, and you'll get to the answers. I think that was probably some of the best advice I've ever gotten. That would be followed up by my mom, who just used to always tell me to don't sell yourself short.
Absolutely. And a personal habit that contributes to your success.
I like to go for a win-win outcome. I think that seeking, there's always room in every situation to seek something other than just a zero sum. There's always this opportunity for everybody to get what they need out of every opportunity.
And a favorite internet resource or phone app?
Well, I tell you, I've been more recently involved with things like open source and Linux. I think this is an amazing environment, free tools, these forums and development groups that allow you to do all of this, access all of this material and training and source code. This stuff just didn't exist when we were in school, and it's such an enabler, and it's a lot of fun. And my favorite phone app is probably Evernote, because I have a really, really small brain.
I use OneNote for everything, and that is my brain on the computer because I don't like to remember things.
Students, use your Evernote. Use your OneNote.
Absolutely. And one book you recommend?
It's a bit of an older book. The book is called Talent is Overrated by Jeff Colvin. I really have liked this book that because it really helps to break the myth that everybody but me has some natural talent that they were born with that makes them successful. And talking about these superstars in sports or in all these other domains that seem to just have this magic talent. And this book really kind of, I think, debunks that myth and talks about how persistent, deliberate practice and love of your craft helps you to really be the success that you can be.
All right. Talent is overrated. And Chris, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we will say goodbye?
I really like the speech that Mark Watney gives gives to his astronaut candidates at the end of the movie The Martian. He's talking about all the things that can and will go wrong in space, and it's going to happen. And then he asserts that, what do you do about it? You just begin. You do the math. You solve one problem and then another problem and another problem. And if you solve enough problems, you get to come home. And of course, in the case for our students, it's really, if you solve enough problems, you get to do something amazing. So just begin. Just do it.
All right, Chris, thanks for that. And with that, we will say goodbye.
Goodbye, and thanks for having me, Jeff.
You're welcome, Chris. I hope you enjoyed our chat today with Chris. Head over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player and share it with a friend. Tune in next week where we talk with Jessica, who is an industrial engineer. Until next time, I hope this chat has helped ignite your passion towards a STEM career.